guys, this is Mrs. Atkinson. I'm here just for a quick video to show you guys this pretty cool decimal strips model that I have here. It should remind you of the fraction strips that we have used in the past to show parts of a whole. And I just wanted to show you that just like we can do it with fraction strips, we can also use these decimal strips to represent parts of a whole as well. So this very top piece here is going to represent our whole. So that is one strip across. And if I were to take that whole and break it equally in half, I would have my 5/10 strip. So I have two 5/10, which equals a whole. So these would be equivalent to a half. A half plus a half would equal a whole. And next you'll see my thirds. And you can see this in fractions. These pieces would represent 1/3 of a whole. And as fractions, they are going to be 33 hundredths. And I want to show you why. That might, not really make a whole lot of sense, or it might seem strange to you. But I'm going to prove to you why that is in a minute. Let's just keep going. So these are my fourths. You'll see I have four pieces that are 0.25 or 25 hundredths. And then I have my fifths. These green ones here are each equivalent to 1/5 as decimals. It's 0.2. And then I have my sixths, which might look really strange to you, but it is 0.166. And you're going to notice there's that little line over the 6, and that's the same with the 3, right? That little line means that that decimal continues on forever and ever. But we just got tired of writing a whole row of 6s or a whole row of 3s. So we have to end it somewhere, and we just use that symbol to show that it repeats. And then we have over here, let's count these. We have 1, 2, 3, 4, 5, 6, 7, 8. So these are our eighths equivalent in fractions. And then we have down here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. These would be our pieces that would be equivalent to tenths, right? And then finally, our 12ths. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. All right, so you're probably saying, well, all right, I get that relationship, Mrs. Atkinson. I remember using fraction strips that were just like this, but how did they get those numbers? Like, how did they get those decimals? And that's what I want to show you today. So I'm going to just set this aside for a minute, but hopefully you can still see it. And I want you just to remember that this was our whole, right? So if I had the number 1 and I'm dividing that number 1 up into smaller pieces, if I wanted to say divided in 2, okay, into 2 pieces, I'm saying my 1 divided by 2, and what would that be? All right, well, we can solve this just like regular division. And remember, fractions are division, right? Okay, so how many times can a 2 go into a 1? Well, it can't. So we're going to put an X right there because it doesn't fit. But now what we can do is we can add a decimal point. And if we add a decimal point here, we're going to also add it directly above, because the number 1 rule with decimals is that we need to line up our decimal points, right? Line up our decimal points, line up our decimal points. You should be singing that at night in your head. All right, so now that I've added a decimal point, I can add a 0. In fact, I can add as many zeros as I want to now that I've added that decimal point. And so now the problem becomes 10 divided by 2. And we do know that a 2 can go into 10. It goes in 5 times. 2 times 5 is 10. And when I subtract, I have no remainder. So I'm done. So you can clearly see now where that 0.5 comes from. When we have 2 pieces, that's where it comes from, dividing 1 into 2 equal pieces. But, all right, Mrs. Atkinson, but how does that work with thirds? You have here that a whole divided by 3 is going to give us in decimals 0.33 with a repeating 3. Well, prove it. So if I have one whole and I'm going to divide it by 3, right? I want to split that whole into 3 equal pieces, just like up here. This is how it goes. Can a 3 go into a 1? I'm going to hold my place with that X. But now I can put a decimal point, and I put one up in my answer too, immediately do that very, very first step. And now that gives me the ability to add as many zeros as I want. So I'm going to add a 0. Now can a 3 go into a 10? 3 times. 3 times 3 is 9. When I subtract, I get 1. Let's add another 0. Bring it on down. I get 10 again. All right, can a 3 go into a 10? It sure can. 3 times, I might have to make my little line a little bit bigger. 3 times 3 is 9. Time to subtract. 10 minus 9 is 1. Let's add another 0. Bring it on down. I get 10 again. Do you guys see that I'm going to keep getting 10 because I'm always going to have 3's up there? So this problem technically has no end. I could keep adding zeros and then making a 10 and then putting a 3 up at the top and keep doing that over and over and over again. So in math, the way that we show that something will repeat and go on and on forever is that we just put this little tiny line over that last digit that repeats, and that is the symbol for it continuing. So we don't even need that 3. We just know that it's 0.33, or in decimal language, we could say 33 hundredths, and that they would repeat. All right, well, I'm getting it now. So if that's true, Mrs. Atkinson, then let's do it for, let's skip down to the 5s. All right, so if I had 1 and I'm dividing it by 5, right, I have my whole and I want to divide it equally into 5 pieces, here's what I would do. A 5 can't fit into a 1. Add a decimal, be sure to add it up top. Now that gives me the ability to add as many zeros as I'd like. A 5 goes into 10 2 times. 5 times 2 is 10. I have nothing left over, so I don't have to put another 0. That's my final answer, 0.2. So 2 tenths is my final answer, and you can see that that works in our decimal strip diagram. And it would keep working. If I went through and did it for the other ones, you would also then see where these numbers are coming from. So I just wanted to quickly show you this. It's something that is going to be more helpful. We don't really use all of these in 4th grade, but as you get older, you may even find it helpful to memorize something like this, just to kind of have those common decimals available in your memory. All right, guys, I hope this little fraction strip video was decimal strip video was helpful for you today. Please like and subscribe to my YouTube channel. I feel like I have to say that for my daughters. They want to see how many viewers or whatever it's called I can get. All right, guys, have a great day.